All right. Good morning, everybody. Today is Friday. Yay, it's Friday, September 15th, 2017. And this is Before the First Cup with Jules here on UCY.TV. Happy Friday, everyone. It is a partly sunny 65 degrees, and I started to see leaves falling from the trees this morning here in upstate New York. So where do we leave off on Wednesday? I titled the show AI Invasion, Hackers, Exploits, DARPA, Guardian Machines, and the Internet of Things. We talked about a lot of things having to do with DARPA scanning 80% of the world's IP addresses to determine whether or not there are botnets living on different networks that could be used by rogue actors to take down the Internet. And without your knowledge, they would be putting an agent onto your network to be able to scan and manipulate and take out, if necessary, the rogue software. Well, I was mentioning how some of these things are going on. There's been an onslaught of just machines that go into comas and don't wake up. And I had my broadcast machine of many years go down like that the other day. Never woke up again. Well, guess what? Last night we had another machine go down. This one happened to be the automated ripping machine that takes the MP3 of the show and rips it to YouTube. Just went to sleep. It's not breathing, though. This one's just off and does not come back on. But very interesting is this technology, this mayhem or for all secure technology that was developed out of Carnegie Mellon University as part of the DARPA Grand Cyber Challenge to combat viruses on the internet and security has been rolling out quietly. That we just have these outages. And I mean, it's all over the place. They're scanning utilizing AI to take a look at the Internet of Things, soon to be your refrigerator and your washing machine, as well as you. We've talked about that before. A few days ago, we covered a story about, oh, look out, because as the sex bots come online, hackers could program them to kill. We found out there's a new hack that can use sonic technology to target cell phones and other Internet of Things devices. If you remember back in December of, and it must have been, I'm going to say 2015 potentially, maybe it was 2016, 21st Century Cures Act passed. And just before that, Obama had passed the Brain Initiative. And we've talked extensively about that and how this whole rollout of $1.5 billion for the Brain Initiative has been aiding artificial intelligence, trying to mimic the human brain. Georgie Porgy Church was involved in using CRISPR to barcode neurons and to be able to get a more precise look at how the brain works. And of course, the 21st Century Cures Act was going to tackle brain disorders as well as brain surveillance. When we first ran across that, we kind of raised an eyebrow. Well, some interesting things have been happening here in the last few days. We, of course, have talked about Dr. Smartphone and how AI is rolling out into medical technology. And not just for simple things like reporting back in an application manually, but also monitoring different vital functions and biostatistics real time to provide a dashboard not only to your doctor, but also to an AI doctor that can then determine at some point in the future whether or not you're going to die. We read about that one that utilized CT scans to determine whether or not you had a 5-year life expectancy. Well, there was a new one we looked at on Wednesday, I believe, about smartphones now being able to assess your brain injuries, and it'll be able to scan your pupils and your pupil reaction to light pulses. Well, here's something that I ran across yesterday. Brain meets Internet of Things. Now, we've talked about Elon Musk and his neural lace project that he's working on now. If you can't beat him, join him. That's kind of what his mantra has been as artificial intelligence comes into play in our everyday lives. If we're not going to be able to be smarter than the machine, then maybe we should merge with the machine. Well, here's a brand new story. And at first it sounded like a joke story, but I don't think it is. When I looked at some of the players from DARPA, I found out that there was a director of Lockheed Martin currently that went to this university. A team of researchers at Wits University in Johannesburg, South Africa, another one of our offshore made science gone mad countries, have made a major breakthrough in the field of biomedical engineering. According to a release published in Medical Express, for the first time ever, researchers have devised a way of connecting the human brain to the internet in real time. Ding-a-ling-a-ling-a-ling. It has been dubbed the Brain Internet, all one word, BRAIN, and the IN is the beginnings of Internet, Brain Internet Project, and it essentially turns the brain into, quote, an Internet of Things node on the World Wide Web. Uh-oh, I warned you of this, guys. Here it comes. The project works by taking brainwave EEG signals gathered by an Emotiv EEG device, and we've talked about them before, connected to the user's head. The signals are then transmitted to a low-cost Raspberry Pi computer, which live streams the data to an application programming interface and displays the data on an open website where anyone can view the activity, i.e. a dashboard. Adam Pantowitz, a lecturer at the Wits School of Electrical and Information Engineering and the project supervisor, said, quote, Brain Internet is a new frontier in brain-computer interface systems. There is a lack of easily understood data about how the human brain works and processes information. Brain Internet seeks to simplify a person's understanding of their own brain and of the brains of others. And it does this through continuous monitoring of brain activity, as well as enabling some interactivity. Now, guys, look at this is using a dangling carrot again. Look how cool it'll be to be able to see not only yours, but your friends' brain activity. But what you're doing is feeding the machine data. And every bit of data you feed the machine is making the machine smarter and allowing the machine to find the chinks in the human armor. That's why there is a caution on this. Pantanowitz said that this is just the beginning, and I've said that before, of the possibilities of this project. And he adds that the team is now aiming to allow for a more interactive experience between the user and their brain. Some of this functionality has already been built into the site, but it is very narrow, limited to stimulus such as arm movement. Brain Internet can be further improved to classify recordings, so they're going to record your brainwaves, put them online through a smartphone app that will provide data for a machine learning algorithm. In the future, there could be information transferred in both directions, inputs and outputs to the brain, says Pantanowitz. Future applications for this project could lead to some very exciting breakthroughs in machine learning and brain interfaces like Elon Musk's neural lace and Brian Johnson's kernel. Data collection from this project could lead to better understanding of how the mind works and how we could take advantage of that knowledge, to augment our brain power. So let's read a little bit about Emotiv. Emotiv.com, EMOTIV. This is whole brain sensing. The brain is a very complex system, and the frontal cortex, the region where most of your conscious thought and decisions are made, conducts much less than a tenth of our total brain activity. Planning, modeling of your surroundings, and interpretation of sensory inputs up to including your perception of reality, memory processing and storage, and the basic drivers of your moods and emotions occur in many functional regions distributed throughout the brain, including the visual cortex at the rear, the temporal cortex at the sides, the parietal cortex behind the crown of your head, and the limbic system deep inside the brain. The limbic system controls your basic moods and emotions, your fight or flight response, your deeper long-term memories, encoding as well as your control of basic bodily functions such as breathing and heartbeat. Most of these deeper functions interact intimately with different parts of your cortex. However, the interaction is quite complex and distributed, and in order to map the true activity of the brain, it is very important to measure signals from many different cortical structures located around the brain's surface. It is not possible to map these signals purely from the frontal or the temporal regions, and determination of the user's complete mental state is very poorly approximated unless the signals from the rear of the brain are also considered. Ding, ding, ding. Remember the 21st Century Cures Act mental health surveillance system they had talked about? Well, I think this is part of the rollout. And of course, these are going to be low cost and widely available out of South Africa or wherever the hell. Actually, this Emotiv, I read they also have offices in Ho Chi Minh, China, which made me raise an eyebrow. Our devices have been developed for research and development applications, and we have maintained an uncompromising approach to the design and development of our mobile EEG systems. We believe that spatial resolution, detecting activity across main cortices of the brain, is crucial to obtaining high-quality data. The wealth of data we have accumulated and analyzed in our detection algorithms, we believe, are second to none. Our sensor tip materials are safe, easy and comfortable for the user for extended periods of time, and all removable parts are replaceable, providing longevity and performance. Our technology is backed and trusted by the scientific, academic, engineering, and media communities and has been validated via scores of independent research papers. Video capture of our 3D brain visualizer application shows activity over the entire brain and across 4 major frequencies, ding ding, of delta, theta, alpha, and beta, and using our 5-channel mobile EEG headset, the Emotiv Insight. Now, remember, guys, when we looked at frequencies and some of these new technologies that the alphabet agencies are working on, this is beyond frightening. Emotiv offers 3 different kinds of detection algorithms, all of them built on extensive scientific studies to develop accurate machine learning algorithms and to classify and grade the intensity of different conditions. Now, think about this. Think about the DARPA Grand Spectrum Collaboration Challenge, where they are looking at companies to provide an artificial intelligence that'll be able to, on the fly, splice and dice radio frequency to be able to beam out whatever they want, anywhere they want, on the fly. Think about that, and then being able to monitor what type of effects that might have real time on the brains that are out there as part of the Internet of Things. We can detect facial expressions, and that would be the muscle artifacts, which are commonly get rejected in laboratory EEG studies, are diverted and classified to map the activation in different muscle groups and eye movement events. Our universal detections can be fine-tuned to each individual to indicate 12 different facial expressions or events. Individuals with partial paralysis, of course, it's all in the name of curing you or keeping you safe, or unusual musculature, can custom train the activations, and these events can be used to animate an avatar, detect specific responses, and they may even be tasked to execute commands. Ding, 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 ding. Performance metrics. Emotiv currently measures 6 different emotional and subconscious dimensions in real time. 1 is excitement or arousal. 2 is interest or valence. 3 is stress or frustration. 4, engagement or boredom, attention and focus. And remember, we read about Disney now using AI to monitor the audience. And a lot of the facial recognition technologies and being able to detect micro expressions, attention, focus, meditation, and relaxation. And we continue to improve and refine our performance metrics algorithms as well as build new detections. These detections were developed based on rigorous experimental studies involving at least 20 to 30 volunteers for each state, where subjects were taken through experiences to elicit different levels of desired state. They were then wired up with many additional biometric measures such as heart rate, respiration, blood pressure, blood volume flow, skin impedance, and eye tracking, as well as observed and recorded by a trained psychologist and also self-reported. Emotiv performance metrics have been validated in many independent peer-reviewed studies. You know, as I'm reading this, I'm starting to get flashbacks back to Clockwork Orange. Do you remember that? When they had him in front of the movie and they were showing him ultraviolence and they had his eyes propped open and they were like watching all of his reactions. This is really beyond horrifying. Guys, this is what the 21st century is going to buy us with the Internet of Things and 5 and coming 6G. And I do have a story about that here somewhere with Qualcomm. So we're going to continue on. So there was another story that came out of Wired.com. I think this was yesterday, 9/13, 2 days ago. Brain-machine interfaces aren't science fiction anymore. Thomas Reardon puts a terry cloth stretch band with microchips and electrodes woven into the fabric, a steampunk version of jewelry, onto each of his forearms. He says the demo is a mindfuck who prefers to be called by his surname only, and that is Reardon. He sits down at a computer keyboard, fires up his monitor, and begins typing, and after a few lines of text, he pushes the keyboard away, exposing the white surface of a conference table in his Midtown Manhattan headquarters of his startup. He resumes typing, but only this time typing on nothing, just a flat tabletop. Yet the result is the same. The word he taps out appear on the monitor, and that's cool, but what makes it more of than just a magic trick is how this is happening. The text on the screen is being generated not by his fingertips, but rather by the signals his brain is sending to his fingers. The armband is intercepting those signals and interpreting them correctly and relaying the output to a computer just as a keyboard would have. Whether or not Reardon's digits actually drum the table is irrelevant. Whether he has a hand is irrelevant. It is a loop of his brain to machine. What is more, Reardon and his colleagues have found that the machine can pick up more subtle signals, like the twitches of a finger, rather than mimicking actual typing. You could be blasting 100 words a minute on your smartphone with your hands in your pockets. And in fact, just before Reardon did his mindfuck demo, I watched his iPhone, and his co-founder, Patrick Keefush, played a game of asteroids. He had one of those weird armbands sitting between his wrist and his elbows. And on the screen, you could see asteroids as played by a decent gamer with tiny spaceships deftly avoiding big rocks and spinning around to blast them with little pixels. But the motions of Keefush was making to control the game were barely perceptible. Little palpitations of his fingers by his palm lay flat against the tabletop, and it seemed like he was playing the video game only with mind control, and he kind of was. In 2017, it has been the coming out year for brain-machine interfaces, a technology that attempts to channel the mysterious content of the 2.5-pound glop inside your skull to the machine, and they are increasingly central to our existence. Ding, ding, ding. The idea has been popped out of science fiction into the venture capitalist circles faster than the speed of a signal moving through a neuron. Ding, ding, ding. Facebook, Elon Musk, and remember, Facebook is Regina Duggan working at Building 8. Elon Musk and other richly funded contenders, such as Braintree's founder, Brian Johnson, have talked seriously about silicon implants that would not only merge us with computers, but that would also supercharge our intelligence. But Control-Labs, which comes with both tech and bona fides and an all-star neuroscience advisory board. Remember, I don't remember his name now. The former director of the National Institute of Mental Health, Tommy Insel, went over to Google. It bypasses the incredibly complicated tangle of connections inside of the cranium and dispenses with the necessity of breaking the skin or skull to insert a chip, which was actually a big task for brain-machine interface. Instead, the company is concentrating on the rich set of signals controlling the movement that travel through the spinal column, which is the nervous system's low-hanging fruit. Reardon and his colleagues at Control-Labs are using these signals as a powerful API between all of our machines and the brain itself. And by next year, they want to slim down the clunky armband prototype into a sleeker watch strap style so that a slew of early adopters can dispense with their keyboards and the tiny buttons of their smartphone screens and put them on their wrists. And remember, they've already been grooming you with that, with those stepper and fitness bands that people have been wearing. The technology also has the potential to vastly improve the virtual reality experience, ding ding, which currently alienates new users by asking them to hit buttons on a controller that they can't see. And there might be no better way to move around and manipulate in an alternative world than with a system controlled by your brain. This is going to be the dangling carrot to suck you right into the machine. Reardon's Control-Labs 47-year-old CEO believes that the immediate practicality of this company's version of the BMI puts it a step ahead of its sci-fi flavored competitors When I see these announcements about brain scanning techniques and the obsession with the disembodied head in a jar approach to neuroscience, we've talked about that from Futurama. I just feel like they are missing the point of how all new scientific technologies get commercialized, which is relentless pragmatism, he says. We're looking for enriching lives, of course, more control over things, over the things around us, and more control over that stupid little device in your pocket, which is basically a read-only device right now with horrible means of output. Whether Reardon's goals are ambitious, I would like our devices, whether they are vended by us or by partners, to be on 1 million people within 3 to 4 years. Ding, ding, he says, but a better phone interface is just the beginning. Ultimately, Control-Labs hopes to pave the way for a future in which humans can seamlessly manipulate broad swaths of their environment using tools that are currently uninvented. And where a robust signal from the arm, the secret mouthpiece of the mind, becomes our prime means of negotiating with the electronic sphere. The initiatives come at a precedent moment for Control-Labs, where the company finds itself perfectly positioned to innovate. The person leading this effort is a talented coder with a strategic bent who has led big corporate initiatives and left it all for a while to become a neuroscientist. Reardon understands that everything in his background has randomly culminated into a humongous opportunity for someone with his precise skills. He is determined not to let this slip by. So this dude was a programmer and he became a neuroscientist. Like, look at that one. Reardon grew up in New Hampshire as one of 18 children, holy shit, in a working class family. And he broke from the pack at age 11, learning to code at a local center funded by the local tech giant Digital Equipment Corporation. Ding, ding. I used to configure DEC systems, and they're one of the very beginnings. A lot of people that I knew that did some work for DEC actually had worked with DARPA at one point. They called us the Gweeps, the littlest hackers, and he took a few courses at MIT, and then at 15, he enrolled at the University of New Hampshire. He was miserable, a combination of being a peach fuzz outsider and having no money, and he dropped out within a year. It was coming up on 16 and was like, I need a job, he says. So he wound up in Chapel Hill, North Carolina, at first working in the radiology lab at Duke, helping to get the university's computer systems working smoothly with the internet. And he soon started his own networking company, creating utilities for the then mighty Novell networking. I remember those days. Eventually, Reardon sold the company, meeting venture capitalist Ann Wibbald in the process, and she hooked him up with Microsoft. Reardon's first job there was leading a small team to clone Novell's key software, and there was a big battle back in those days. It was back in the 90s. So it could be integrated into Windows. And still a teenager, he wasn't used to managing, and some people reported to him, called him Doogie Howser. Yet he stood out as exceptional. You're exposed to a lot of types of smart people at Microsoft, but Reardon would kind of rock you, he says. Brad Silverberg, then head of the Windows and now VC invested in Control-Labs. In 1993, told you, Reardon's life changed when he saw the original web browser. He created the project that became Internet Explorer, which, because of the urgency of the competition, was rushed into Windows 95. I was there at that time, in time for a launch, and for a time that was the world's most popular browser. So in years later, Reardon left the company frustrated by the bureaucracy and worn down from testifying in the antitrust case. And we've talked about that at length with Bill Gates and Microsoft involving the browser he helped engineer. Reardon and some of his browser team compatriots became a startup. And, I'm going to tell you what, if he was the inventor of that browser, we talked about that antitrust lawsuit. And the day that Bill Gates came out, I remember that distinctly. I was right in the lizard's pit at that time. And the day Bill Gates came out to say that the antitrust lawsuit was over and they were going to do things the way that they were told, because that was the day he sold us all out. The fact that this Reardon, who was in the middle of this brain-computer interface technology, was a part of that team was very interesting to me as well. He said that some of his browser team compatriots then began a startup focused on wireless internet. Our timing was wrong, but we absolutely had the right idea. And then Reardon made an unexpected pivot. He left the industry and enrolled as an undergraduate at Columbia University. to major in the classics. And the inspiration came from a freewheeling 2005 conversation he had with celebrated physicist Freeman Dyson, who mentioned his voluminous reading in Latin and Greek, and arguably the greatest living physicist isn't telling me to do science. He told me to go read Tectus. So I did at age 30. And in 2008, Reardon did get his degree in classics, magna cum laude. But before he graduated, he began taking courses in neuroscience and fell in love with the lab work. It reminded me of coding, of getting your hands dirty and trying something and seeing what worked and then debugging it. He says he even decided to pursue it seriously to build a resume for grad school. And even though he was still well off from his software exploits, he wanted to compete for a scholarship, and he got one from Duke University to do basic lab work. He transferred to Columbia, working under renowned neuroscientist Thomas Jessel, who is now a Control-Labs advisor, along with other luminaries like Stanford's Krisha Sennoy. And according to his website, the Jessel Lab studies system and circuits that regulate movement, which cause the root of all behavior. This reflects Columbia's orientation in the neuroscience divide between those concentrating on what purely goes inside a brain and those who study the brain's actual output. Now, interesting, because Columbia and Duke and Columbia and Stanford have all been parts of this technology that we have been talking about, and a lot of the spook agencies have come out of places like that. Though a lot of glamour is associated with those who try to demystify the mind through its matter, those in the latter camp quietly believe that the stuff the brain makes us do is really all the brain is for. Neuroscientist Daniel Wolpert once famously summarized this view. We have a brain, he says, for one reason and one reason only, and that is to produce adaptable and complex movements. There is no other reason to have a brain. Movement is the only way that you have of affecting the world around you. And that helped shape Control-Labs, which got its start when Reardon began brainstorming with two of his colleagues in the lab in 2015. These co-founders were Kafish and Tim Macchinato, who got their doctorates a bit before Reardon did and began setting up the company. During the course of his grad study, Reardon had become increasingly intrigued by the network architecture that enables volitional movement, which are skilled acts that don't seem complicated, but actually require precision, timing, and unconsciously gained mastery. Things like grabbing that cup of coffee in front of you and raising it to your lips and not just shoving it through your face, he explains. Figuring out which neurons in the brain issue the commands to your body to make those movements possible is incredibly complicated. And the only decent way to access that activity has been to drill a hole in your skull and stick an implant in the brain and then painstakingly try to figure out which of the neurons are involved. What good thing. You can make some sense of it, but it takes a year for someone to train one of those neurons to do the right thing, say to control a prosthesis, says Reardon. But an experiment by Reardon's co-founder Macchiato opened up a new possibility. Macchiato was, like Reardon, excited about how the brain controlled movement, but he had never really thought about the way to do brain machine interface was to plant electrodes in the skull. I never thought that people would do that to send text to each other, he says. Instead, he explored how motor neurons, which extend through the spinal cord to actual muscles in the body, might be the answer. He created an experiment in which he removed the spinal cords of mice, poor little mousies, and kept them active so he could measure what was happening with the motor neurons. And it turned out that the signals were remarkably organized and coherent. You could understand what their activity was, he says, and the two young neuroscientists and the older coder turned neuroscientist saw the possibility of a different way of doing brain-machine interfaces. If you're a signal person, you might be able to do something with this, says Reardon, recalling his reaction. And the logical place to get a hold of these signals is in the arm, as human brains are engineered to spend a lot of their capital manipulating the hand. And the Control-Labs was far from the first to understand that there is a value in those signals. A standard test to detect neuromuscular abnormalities uses the signals in what they call an electromyography, which was commonly referred to as an EMG. In fact, in its first experiments, Control-Labs used standard medical tools to get its EMG signals before it began building custom hardware. The innovation lies in picking up EMG more precisely, including getting those signals from individual neurons than previously existing technology, and even more important, figuring out the relationship between the electrode activity and the muscles so that we can translate EMG into instructions that computers can control. So we have two competing brain-computer interfaces to the internet, it seems, over the last week. One is using EEG and one is using EMG, and they both are able to collect readings about you and feed them to some sort of interface. Well, I ran across another story. What comes after smartphones? And this is out of Quartz.com. Maybe implants or not. The guy actually has an EEG helmet on or little cap. It would be the ultimate user interface. A device the size of 2 stacked nickels that allows your thoughts to control a computer. The only catch is that it'll have to be implanted in your brain. Well, that is what DARPA's Cutting Edge Research Unit is working on as part of President Obama's Brain Initiative, a concerted push to advance neuroscience. It is also what Qualcomm's Chief Technology Officer, Matt Grobe, believes could come to market for consumers when 6G, not 5G, we're looking forward to 6G, or so-called sixth-generation wireless technologies arrives, hence putting you real-time, forever, on the Internet of Things. When you look at 1G being for voice or for your ears, and 3G through 5G are for data and your eyes or for a vision service, perhaps 6G will go beyond the head-mounted displays to introduce direct neural interfaces, says Grobe at Quartz Next Billion conference held in San Francisco on October 13th. Qualcomm is a member of the industry group that has been formed to support the DARPA project with access to its rapid prototyping and manufacturing of neuroengineering components. Qualcomm, which makes smartphone chips, ding ding, was a developer of the LTE technology behind 4G as well and is well positioned to contribute. This will give DARPA access to charging and powering solutions for brain implants, ultra-low powered electronics designed, and data compression, as well as processing technology, according to DARPA's PDF. Implants could feed sensory data into the brain at high resolution, and it could be one way to address sight or hearing deficits, says DARPA, when the Neural Engineering System Design Program was announced. And today's best computer-brain interface systems are like two supercomputers trying to talk to each other using 35-year-old 300 baud technology. Low-power brain implants hooked up to an ultra-high-speed 6G data network would certainly make Google Glass and Snap spectacles look antiquated, so don't hold your breath. New generations of wireless technology have generally been introduced in 10-year phases, which puts 6G's arrival at around 2030. Dun, dun, dun. Guys, this is where we are headed. And don't worry about it, Futurism.com released a story, and this one was actually April 5th, 2017, but I saw this morning. We just created an artificial synapse that can learn autonomously. Dun, 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 dun. So as we understand more about the brain, and we can suck all kinds of data out of the brain and take a look at the brain's alpha, theta, beta waves and different things that are going on and different muscular movement. The development and advances in artificial intelligence have been due in large part to technologies that mimic how the brain works. And in the world of information technology, such AI systems are called neural networks. These contain algorithms that can be trained, among other things, to imitate how the brain recognizes speech and images, and also how to move. Found out Google's DeepMind actually taught itself how to walk, run, and jump using simulated environments. And however, running an artificial neural network consumes a lot of time and energy. Well, now researchers from the National Center for Scientific Research in Thales and the University of Bordeaux in Paris and the and Evry have developed an artificial synapse called the memristor. Ding, ding, Joe Friday, directly on a chip. And it paves the way for intelligent systems that required less time and energy to learn and that can also learn autonomously. In the human brain, synapses work as connections between neurons, and the connections are reinforced and learning is improved the more these synapses are simulated. The memristor works in a similar fashion. It is made up of thin ferroelectric layers which can be spontaneously polarized that is enclosed between two electrodes. In using voltage pulses, the resistance can be adjusted like biological neurons. The synaptic connections will be strong when the resistance is low and vice versa, and the memristor's capacity for learning is based on this adjustable resistance. AI systems have developed considerably in the past few years, and neural networks built with learning algorithms are now capable of performing tasks which synthetic systems previously could not do. So look out, because they are working on it. It's the big pulsating brain in the sky. For instance, intelligent systems can now compose music, play games, or beat human players, or just do your taxes, or even be a lawyer. And some can even identify suicidal behavior or differentiate between what is lawful, ding ding, and what isn't. And thanks to AI's capacity to learn, the only limitation of which is the amount of time and effort it takes to consume the data and to serve it at its springboard. With the memristor, this learning process can be greatly improved. Work continues on the memristor, particularly on exploring ways to optimize this function. For starters, the researchers have successfully built a physical model to help predict how it functions. Oh, good thing. And their work is published in the journal Nature Communications. Now, what's concerning about all this learning, deep learning, connecting our brains to the machine, and being able to surveil and look for lawful and unlawful actions online, all the Internet of Things connected devices, soon to be you. There was a story that came out of phys.org back on September 9th, just a few days ago, 2017. We talked about DARPA mapping 80% of the world's IP addresses and being able to put an agent on them to determine whether or not you are quote unquote infected by some sort of botnet and otherwise scary and bad for the internet. Data swamped U.S. spy agencies are now putting hopes on artificial intelligence. Swamped by too much raw intelligence data to sift through, U.S. spy agencies are pinning their hopes on artificial intelligence to crunch billions of digital bits and to understand events around the world. Ding-a-ling. Don Merrick's, a Central Intelligence Agency's Deputy Director for Technology Development, said this week the CIA is currently involved in 137 different AI projects, many of them with developers in Silicon Valley. Who would have figured it? These range from trying to predict significant future events by finding correlations in data shifts and other evidence, and to having computers tag objects or individuals in a video that can draw the attention of intelligence analysts. Officials with other key spy agencies at the Intelligence and National Security Summit in Washington this week, including military intelligence, also said that they were seeking AI-based solutions for turning terabytes of digital data coming in daily into trustworthy intelligence that could be used for policy and battlefield action. Like what? Sending out an online electrical pulse to put a system on a bad network to sleep forever. Maybe, just maybe. They talked about that. I don't remember his name. The former head of the NSA. Oh, what was his name? He came out of Syracuse. Who left, had said that they had that ability to take out machines remotely. Utilizing technology, don't think that they wouldn't do that if they decided or determined that you were a problem network. But anyway, AI has widespread functions from battlefield weapons to potential to help quickly rebuild computer systems and programs brought down by hacking attacks, is one official described. But a major focus is finding useful patterns in valuable sources like social media. Combining social media for intelligence in itself is not new, says Joseph Garton, head of the CIA's Kent School, which teaches intelligence analysis. And what is new is the volume and the velocity of collecting social media data. He says, in that example, artificial intelligence-based computing can pick out keywords, ding, and names, but it also finds patterns in data that correlate with other events and continuously improve on that pattern finding. AI can, quote, expand the aperture of the big eye that's watching you of an intelligence operation looking for small bits of information that can prove valuable, according to Chris Hurst, the chief operating officer at Stabilitas, which contracts with the U.S. intelligence community on intel analysis. Human behavior is data, and AI is the data model. Ding, ding. And I told you, behavior analytics. And where the patterns are, we think AI can do a better job. The volume of data that can be collected increases exponentially with advances in satellite and signal intelligence collection technology. Ding, 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 ding. And if we were to attempt to manually exploit the commercial satellite imagery we expect to have over the next 20 years, we would need 8 million imagery analysts, says Robert Cordillo, director of the National Geospatial Intelligence Agency, said in a speech in June. How many intelligence agencies do we have? Jesus Christ. Cardillo says that his goal is to automate 75% of analyst tasks with a hefty reliance on AI operations that can build on what they learn automatically. Big pulsating surveillance, brain in the sky. Washington's spies are not the only ones turning to AI for future advantage. Russian President Vladimir Putin, we talked about this, declared last week that the artificial intelligence is a key for power in the future. Whoever becomes the leader in the sphere will become the leader of the world, he says. The challenge, U.S. officials say, is gaining trust from consumers. Ding, ding, ding. That is the whole oxytocin project by DARPA for their intelligence product, like policymakers, White House, and top generals, to trust the reports that have significant AI components. We produce a presidential daily briefing, and we have to be really, really good with our evidence for why we reach the conclusions that we do. You can't go to leadership and make a recommendation based on a process that no one understands, right? And that has been a problem for a long time. Nobody understands how AI works, the dark heart of AI. Well, not only is Georgie Porgy Church and some of his affiliations with the Weiss Institute finding ways to use CRISPR to barcode neurons, but the Weiss Institute is also leading an IARPA-funded brain mapping consortium, and IARPA is the Intelligence Advanced Research Project Agency, which is the intelligence agency's DARPA. The Weiss Institute for Biologically Inspired Engineering at Harvard University announced a cross-institutional consortium to map the brain's neural circuits with unprecedented fidelity. The consortium is made up by $21 million contracts from the Intelligence Advanced Research Projects Agency, more affectionately known as IARPA, and aims to discover the brain's learning rules and synaptic circuit design, further helping to advance neurally derived machine learning algorithms. The consortium will leverage the Weiss Institute's FISSEQ, the fluorescent in situ sequencing method, to push forward neuronal connectomics, which is the science of identifying the neuronal cells that work together to put about specific brain functions. The FISSEQ was developed in 2014 by Weiss Core faculty member who, oh, you guessed it, Georgie Porgy Church and colleagues. And unlike traditional sequencing technologies, it provides a method to pinpoint this precise location of specific RNA molecules in intact tissue. The consortium will harness this FISSEQ capability to accurately trace the complete set of neuronal cells and their connecting processes in the intact brain tissue over long distances, ding, 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 which is currently difficult to do with other methods. Awarded a competitive IARPA Micron's contract, the consortium will further the overall goals of President Obama's BRAIN initiative, which aims to improve the understanding of the human mind and uncover new ways to treat neuropathological disorders like Alzheimer's, schizophrenia, autism, and epilepsy, and as well as depression, I read. And the consortium's work, and then apply it on a dashboard online that anyone can see. The consortium's work will fundamentally innovate the technological framework used to decipher the principal circuits and neurons used to communicate and fulfill specific brain functions, maybe even control them in the future. The learnings can then be applied to enhance artificial intelligence in different areas of machine learning, such as fraud detection, pattern and image recognition, and self-driving car decision making. Oh, it's time to turn Johnny down. He's getting a little excited. I mean, guys, where is all this headed? I mean, I think I've done a pretty good job in this show outlining all these connecting points, and this is all coming within the last year and a half since this 21st Century Cures Act with the BRAIN Initiative included. And all this technology that is going to connect us to that internet of pulsating things that'll put everything on a dashboard and put the AI doctor in charge to be able to decide whether or not you are operating within parameters. Historically, the mapping of neuronal paths and circuits in the brain has required brain tissue to be sectioned and visualized by an electron microscope. Complete neuron and circuits are then reconstructed by aligning the individual electron microscope images, and this process is costly and inaccurate due to the use of only one color, which is gray. Says Church, who is the principal investigator for the IARPA Micron Consortium. We are taking an entirely new approach to neuronal connectomics, intensifying colorful barcodes. This is the barcoding project that should overcome this obstacle, and by integrating molecular and physiological information, we are looking to render a high-definition map of neuronal circuits dedicated first to specific sensations. It's time to give them a zap. In the future, to behaviors and cognitive tasks. Church is a professor of genetics at Harvard Medical School and a professor of health sciences and technology at MIT. And to map neural connections, the consortium will genetically engineer mice so that each neuron is barcoded throughout its entire structure with a unique RNA sequence, a technique called Boanic, which is the barcoding of individual neuronal connections, developed by Anthony Zador at Cold Spring Harbor Laboratory. Thus, a complete map representing the precise location, shape, and connection of all neurons can be generated. The key to visualizing this complex map will be the FISSEQ, which is able to sequence the total complement of barcodes and then pinpoint their exact locations using a super resolution microscope. And importantly, the FISSEQ analysis can then be applied to an intact brain tissue, and the error-prone brain sectioning procedure that is part of a common brain mapping study can be avoided, and long neural processes can be more accurately traced in larger numbers and at a faster pace. The multidisciplinary consortium spans 6 different institutions. So let's see who's involved. In addition to Church and the Weiss Institute's efforts, will be Samuel Inverso, PhD, who is staff software engineer and co-investigator for the project. Complementing the Weiss teams are also co-principal investigator Anthony Zador, Alexei Kalukev, PhD, and Jay Lee, PhD at Cold Spring Harbor University. Adam Marblestone, PhD, and Liam Paninsky, PhD, are co-investigators at MIT and co-principal investigator at Columbia. Ding, ding, ding. The Harvard-led consortium is partnering with another Micron's team led by Tang Sing Lee, a PhD at Carnegie Mellon, who would have guessed it, as principal investigator under a separate multi-million-dollar contract with Sandra Kuhlman, PhD of Carnegie Mellon, and Andrew Ewell of Johns Hopkins University, who also has the biggest brain database, and co-principal investigator to develop computational models of neural circuits and a new generation of machine learning algorithms by studying behaviors of large populations of neurons and behaving animals, not misbehaving animals, as well as the circuitry of these neurons revealed by the innovative methods developed by this consortium. Oh my God, this is very exciting to see how technology developed at the Weiss Institute is now being instrumental in showing how specific brain functions are wired into the neuronal architecture. The methodology implemented by this research can change the trajectory of brain mapping worldwide, says Weiss Institute founding director Donald Ingerber, MD and PhD, who is also the Judah Folkman Professor of Vascular Biology at Harvard Medical School and the Vascular Biology Program at Boston Children's Hospital, as well as Professor of Bioengineering at the Harvard John A. Paulson School of Engineering and Applied Sciences. So there you have it. There are some big names and big institutions who are behind some of these mapping technologies that are being rolled out to do things such as controlling asteroids or controlling your keyboard to be able to type things without any effort at all. How nuts is that? So as we start talking about invading your body, there were a couple more stories that went a little beyond the brain, and it's along the same lines of some of the stuff that we have talked about before and becoming part of the Internet of Things, and that would be nanobots and getting nanobots in your blood and being able to track nanobots in your blood, making more than just your brain, but your whole body as a member of the Internet of Things. September 13th, 2017, out of theengineer.co.uk, tracking of medical nanobots comes a step closer. A new magnetic resonance technology could be used to locate quote-unquote smart pills inside of your body. Medical nanobots have long been a dream of science fiction, minute devices that can roam the bloodstream and the organs, looking for and even treating diseases and other conditions on the fly. And as the engineer has reported, the first step toward these technologies is being taken around the world with targeted drug delivery systems that bind to specific sites and release specifically targeted medicines. Other research has looked at smart pills, devices carrying tiny cameras and other miniaturized technology inside of the body to help clinicians treat patients. And one problem with such a device is tracking their location once they have been digested. Researchers from Caltech have now borrowed a technique for magnetic resonance imaging to help tackle this problem. The team, led by electrical engineer Azita Imani and a chemical engineer Mikhaila Shapiro, have developed a technique known as ATOMS, which is the addressable transmitters operated as a magnetic spin, which allows smart pills, also known as capsule endoscopes, to be located in the body using magnetic fields. The technique uses a silicon chip that contains a set of integrated sensors, resonators, and wireless transmission technologies that allow them to mimic the magnetic resonance property of atoms. The key principle of MRI is that the magnetic field gradient causes atoms at two different locations to resonate at two different frequencies, making it easy to tell where they are. We wanted to embody this elegant principle in a compact integrated circuit. The ATOMS devices also resonate at different frequencies depending on where they are in a magnetic field. Well, ding ding, again using frequencies. Imani and Shapiro enlisted the help of Manuel Montague, a bioengineer and former doctoral student in Imai's lab, now working at the Elon Musk's founded neurotechnology company Neuralink, to design a chip that would embody their idea. Montague is a lead author on a paper in Nature Biomedical Engineering describing the research. The chip Montague designed has a surface area of 1.4 millimeters and contains a magnetic field sensor, integrated antenna, a wireless powering device, and a circuit that adjusts its radio frequency based on a magnetic field strength that the sensor detects to wirelessly relay the chip's location. This chip is totally unique. There are no other chips that operate on these principles, said Montague, and integrating all of the components together in a very small device while keeping the power low was a big task. The paper describes how successful tests on this device worked inside of mice. The researchers stress that this device is only preliminary, so don't worry about it yet. Shapiro envisages further steps that would incorporate sensors into small pills that could detect pH, temperature, pressure, and blood sugar concentrations and relay those to doctors, ding, 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 or use them to trigger and control the release of drugs. You could have a dozen microscale devices traveling around inside your body, taking measurements and intervening in disease, he says. And these devices can all be identical, but the Adams devices would allow you to know where they are, and they can all talk at once. I'm referring back to the science fiction in the 1960s called Fantastic Voyage, when miniaturized submarines were used to find and dissolve life-threatening blood clots. Shapiro added that instead of sending a single submarine, you could send an entire flotilla. Oh, no. In your blood. But for now, the team has a more modest target in sight. The next goal is a device that you can not only detect, but that can simultaneously relay and sense body states. We want to build a device that can go through your gastrointestinal tract and not only tell us where it is, but to communicate information about various parts of the body and how they are doing. So chew on that one. Because they are working on that fast and furious. We had Kurzweil talk about that a long time ago, and there's been a lot of funding that has gone into things of that nature. And as we are reaching the very end of the show here, there is one other story that may not come up here as we are going into not responding mode, of course. But make sure everybody sticks around, because remember, it's Friday, and I cut manically for the weekend, so you can have all new shows to listen to and all kinds of great stuff that comes up on the weekend. It doesn't look like it's going to let me get it. So maybe I should sing, because I'm not hearing anything. Ghost in the Machine. Well, hold on one second, because if I can get there quick, maybe I can get this very last story about nanobots in your blood. And there were two, which I don't find surprising. And there we go. Oh yeah, to treat stomach ulcers. That's the next one. All right, guys, hang on to Friday, and I will catch up with you Monday.